Okay, so this mini lecture is going to very carefully focus on direction of acceleration. So I already have the chart up that is in the worksheet called Discovery Direction of Acceleration as a preparatory thing, and we're going to go through that worksheet and really focus on using it to enable us to understand what direction of acceleration is all about and what information, more importantly, what information we can get out of knowing the direction of the acceleration. So the worksheet itself should be in your notes, and the scenario description should be in the notes for this mini lecture. So scenario number 1 tells us, while traveling to the left, my velocity changed from minus 5 meters per second. That minus does tell us it's to the left, so there's some redundant information there, to minus 10 meters per second in 1 second. So let's go through the table and see what our variables are, what our values are for these different elements, and then what we know by just reading about it. So scenario 1, our initial velocity is minus 5 meters per second. It tells us it goes from 5, it starts at 5, to 10, so it gets to minus 10 meters per second. So my change in velocity, delta V, is equal to V final minus V initial. So minus 10 minus a minus 5, I get minus 5 meters per second. So my change in velocity is minus 5. What is my time? It says it does this in 1 second. What is my acceleration? We learned how to calculate acceleration in a previous mini lecture. So my acceleration, it is an average acceleration calculation, but again, this is always constant for our purposes, is my change in velocity over the time the motion is happening. My change in velocity is minus 5. My time is 1, and I get minus 5 meters per second, or meters per second squared. So my calculated acceleration is minus negative 5 meters per second squared. So that's all the math and the numbers, and now let's use that information and the scenario description to fill in the more conceptual bracket, this pink square, which is what we're going to use to help us think about the conceptual idea of direction. So what is the object's direction of motion? Well, the scenario reads it's moving to the left. So the object's direction of motion is certainly to the left, which we define as being negative. So the object's direction of motion is negative. And that also is shown here by our initial and final velocities. What's the object doing? Is it speeding up or is it slowing down? Well, it was going 5 meters per second leftward. Now it's going 10 meters per second leftward. That's fast. That's getting faster. It was 5, now it's 10. So the object is speeding up. It's going from 5 to 10. What's the direction of the acceleration? Well, that's just the symbol in front of that acceleration value. It's negative. All right, so let's look at the second scenario. The second scenario reads, while traveling to the right, my velocity changed from 5 meters per second to 3 meters per second in 1 second. So now I'm traveling to the right. I started at positive 5. That positive tells me it's to the right. That gives me that direction of motion right away. I'm to the right. I go from 5 to 3. My change in velocity, my final 3 minus my initial 5, is negative 2. 3 minus 5 is negative 2. The amount of time I did that in is 1 second. And therefore my acceleration, change in velocity over time, negative 2 over 1 is negative 2. So we've already defined that my direction of motion is positive. I'm moving to the right according to the scenario. My velocities are positive. That tells me I'm moving to the right. So my direction of motion is positive. What am I doing? Speeding up or slowing down? Well, I was going 5 meters per second to the right. Now I'm going 3 meters per second to the right. I'm going slower. I'm going slower. I'm slowing down. My direction of acceleration, that is negative. So I put that negative over there. All right, scenario number 3. While traveling to the left, have that information right away. My velocity changed from -5 to -3. -3 minus a -5, my change in velocity is a +2. I do that in 1 second. My change in velocity per time, 2 over 1, is a +2, positive direction of acceleration. What am I doing? Well, I was moving 5 meters per second to the left, and now I'm only going 3 meters per second to the left. I'm getting slower. I'm still moving left. I'm getting slower as I do it. So I'm slowing down. All right? And our last scenario tells us that while I'm traveling to the right, my direction of motion is to the right, I move from 5 meters per second initially to 10. These are both positive. Now, I'm going to point out real quick that notice I did not put the positive here. You can, it's perfectly fine if you do. If you do not put a positive, it is assumed positive. Okay, that's a convention. If you don't put that positive, our convention is that it's positive. All right, so 5 to 10, my final position minus my initial position is a +5 meters per second. I do that in 1 second. So my change in velocity per time is a +5 meters per second squared. A positive direction. What am I doing? Well, I'm going from 5 to 10. I'm moving to the right. I'm moving at 5 meters per second, and I'm really moving at 5 meters per second. I'm speeding up. So here are all 4 different scenarios relating what an object is doing to its acceleration. And so now we're going to look at that and see if we can deduce some ideas about direction of acceleration. If your chart does not match this chart, and you should have done it on your own first, you need to pause this video and really relook at what you did. This is important. We have huge misconceptions about direction of acceleration and what it means to have a negative or a positive acceleration. So make sure this matches and you understand how you might have done something in error. Make sure to talk to me if you aren't sure. All right. So this worksheet goes on to help us kind of get some generalizations. It says, looking at the direction of acceleration column, so that's this one. When the direction is negative, what's happening? Are you always slowing down? And that's what we'll hear. That's the misconception, that negative acceleration means slowing down. Is there evidence of that in that final column? Well, here I have a negative acceleration, and I'm indeed slowing down. So a negative acceleration can be slowing down. But here I have a negative acceleration, and I'm speeding up. So if I just look at the direction of acceleration, I have no idea if I'm speeding up or slowing down. I could be doing one or the other. If I just saw this column and I saw this negative, well, I'm slowing down in that scenario. But if I saw this negative, well, I'm speeding up in that scenario. This is important. Negative acceleration does not tell us an object is slowing down. Similarly, what about if the object has a positive acceleration? If I have a positive acceleration, I could be speeding up, like in this scenario. If I have a positive acceleration, I could be slowing down, like in this scenario. So a positive acceleration, it's often believed it tells us we're speeding up, but it doesn't. It does not tell us an object is speeding up. So the direction of the acceleration alone, if all I know is the object has a negative acceleration, if that's the only thing I know, can I say whether the object is speeding up or slowing down? If I tell you the object has a negative acceleration of 3 meters per second squared. Can you tell me it's speeding up or slowing down? No, you can't. So the direction of acceleration does not indicate how velocity is changing. It does not indicate how velocity is changing. It does not indicate that the object is getting faster or getting slower or turning a corner. All right. Well, does it indicate could it indicate something else? Could it indicate the direction the object is moving? I mean, after all, a positive velocity tells us we're moving to the right, and a negative velocity tells us we're moving to the left. Does a positive acceleration tell us we're moving to the right? And does a negative acceleration tell us we're moving to the left? Well, let's look at our scenario. If the only thing I knew was that the object had a positive acceleration, it could be moving to the right. But in scenario 3, a positive acceleration and the object's moving to the left. Similarly, in scenario 1, the object had a negative acceleration and it was moving to the left. It also had a negative acceleration in scenario 2.
There's nothing to repeat.
Apparently Siri heard me. It has a negative acceleration in scenario 2. It's moving to the right. So this
Okay, I found this on the web for negative acceleration.
There you go. We are going to turn that off. Sorry about that. So the direction of acceleration does not indicate direction of motion like velocity does. So what does it indicate? It doesn't tell us what the object's doing, how the velocity is changing. It doesn't tell us what direction the object is going. So what does it tell us? Well, it tells us the direction of the change. And what does that mean for motion? Well, if we want to put that into useful sorts of ideas, is it speeding up or slowing down, we actually have to look at a couple of things. And this is where we can hang our hat. Can we see some patterns in this? If the acceleration and the velocity have the same direction, what do we notice? If the acceleration and the velocity have opposite directions, what do we notice? Well, let's look at them. They have the same direction. So here we have positive motion, positive acceleration. Here we have negative motion, negative acceleration. So the acceleration and motion direction. So acceleration direction, let's be a little bit careful, and motion direction are the same. Both positive or both negative. What do we notice? We get speeding up. So in both these cases, the object speeds up. I'm moving to the right and I'm changing my velocity to the right. I'm making those numbers more and more right. I'm getting faster. I'm moving to the left and I'm changing velocity to the left. I'm making those numbers more and more negative. I'm getting faster. So when the acceleration and motion are in the same direction, we speed up. Hopefully you've thought ahead, and when the acceleration and the motion are opposite, negative, positive, positive, negative, the object does what? Slows down. So if the acceleration direction and motion direction are opposite, we get slowing down. So if I am moving to the right, but I'm trying to change my motion leftward, I'm resisting and pulling it back. I'm trying to make the change go to the left. I'm going to slow it down. And if I'm moving to the left, I'm trying to make that change to the right, I'm going to slow it down. So when the acceleration direction and motion direction are opposite, we can say something. We can say that the object is slowing down. So keep this worksheet handy, because as we define problem solving and we make estimates of what we expect and we compare our answer to what we think should be happening with the motion, some of this will come into play. Should the object have a positive acceleration if it's slowing down? Well, maybe if it's moving to the left to begin with, and we know what direction to assign an acceleration, or that we expect if we're determining an acceleration. So this is a very important, it's not intuitive in terms of positives and negatives with acceleration. It's a very big misconception in introductory physics, and we have to keep wrestling with it, keep working with it. Negative acceleration does not mean slowing down. Positive acceleration does not mean speeding up. The sign of the acceleration does not indicate how the object is changing its velocity. It doesn't mean it's moving to the left or moving to the right. It doesn't indicate the direction of motion. If we want to think about how the object is changing, we have to look at the motion and the acceleration together. All right? So keep working with this and keep wrestling with that misconception, and we'll get there. All right.